Cool. Okay. If you're ready, we will dive in so we can let you go back to your day.
All
Uh,
right.
Welcome back, everybody. As you know, I'm Eli, the computer guy with Silicon Dojo. We do these fireside chat calls with people in the technology industry, basically to show you folks what the real world of the tech industry is like. I've done education since 2009, and one of the big problems now is everybody wants to do this job. They have no idea what this job actually is. So I'm bringing in real people so they can say what they do, why they're doing what they're doing, and you all can figure out what it is you want to do in life. Since this is a Zoom call, if you're actually on it, if you raise your hand or put a comment in the comment stream, we can actually get to your individual questions. And there will be a YouTube video. This is being recorded, so there will be a YouTube video that goes up in approximately 24 hours. So we have Dow here, co-founder and CEO of Contextual AI, right?
That's
Cool.
right.
And you're like an impressive person, right? So you're the co-founder and CEO of this. You're an adjunct professor at Stanford. You were head of research at Hugging Face, and you were a research lead at Meta's fundamental AI research team, right?
That's right.
That's cool. So I guess for a lot of the people at home, the first question to ask is, I've got to believe the paychecks at Hugging Face and Meta were pretty decent. So why would you go into the startup world and risk things?
Yeah, I guess especially Meta is famous for paying well. I mean, for me, I always wanted to be an entrepreneur. I started my first company when I was 18, and always wanted to start another one. But after my PhD, fair basically, so Meta came and said, "Hey, do you want to join?" So I couldn't really say no to that. And then learned a lot there. Spent 5 years at Meta, so quite a long time. And then after that, it was like, oh, maybe I should do a company now. But I felt like I still had a lot to learn about how to do these fast-moving AI startups. So decided to join one so that I could learn firsthand what to do. So that's why I went to Hugging Face, and then ChatGPT happened. The whole narrative changed. We knew that one of the core building blocks for solving a lot of the issues with the original ChatGPT, so hallucination and attribution and things like that, we knew that RAG would be a part of the solution because RAG was one of the things I was involved with at Meta. We also knew that we could do a lot better than RAG, so it just made a lot of sense to start the company then. So that's why we did it.
That's cool. So in Silicon Valley, in that world, because we hear about like all these non-compete contracts and all that, was it pretty easy to do this, or did people kind of get in your way, or
California, so non-compete contracts don't apply in California, and for good reason. I think like non-compete contracts should not be a thing in the world. Yeah, it's a very vibrant ecosystem here, and so lo lots of um, good groups of people kind of in very close proximity to each other. So very deep technical people, very good academics, and very good venture capitalists, all very close to each other. So that just creates this very special mix. And that's why Silicon Valley is so great.
Oh, that's cool. So when we talk about RAG, so this is retrieval augmented generation. And so basically this is so normally when you ask an LM for the student, so when you ask an LLM, it's collected all of the information apparently from all over the world. And so you ask it a question and it only knows that information. So with RAG, what you're doing is you're adding your additional information to the prompt. So basically you can say, out of this information, give me the answer to this problem. So it says here that you're on the team that pioneered RAG back in the day. So what is I mean like because I mean you look at it now and it's kind of weird like with these things. Like I pioneered that and you look at it, it's like, well, that seems kind of simple. Like I don't know,
Yeah.
back in 2020, was it actually simple? Or like when you say pioneered, is that as cool as it sounds?
Yeah. I don't know if it is as cool as it sounds. I mean, it was a very special time, I think, in AI where things were just starting to work a little bit for the first time, and these generative models were starting to create useful outputs. And So I think as with all of these kind of discoveries and like people pioneering certain things, uh, it almost never is that there's like one person or one team that comes up with it. There's usually all kinds of different related things going on at the same time, and then the team that does it is really just right place at the right time. So for us, we were very lucky that the core building blocks were there. So we had a generative model. It was called BART. It was like a generative version of BERT.
Mhm.
Um, and then we had FACE and DPR, which was the first vector database and sort of high quality embedding model. And so we just combined those two things, and that was RAG. But the reason we combined the two things was because we were interested in trying to ground these generative models into different types of underlying ground truth data. So the big problem with language models, and it still is the big problem, is that you have to train them on a lot of data, but then as soon as you're done training, new things happen, or things might have happened that were not in your training data, and then the model just doesn't know about it. So how can you get that information into a generative model without having to train the model on that data? That was really the kind of core research question that we were interested in at the time. And so that's 5 years ago now. And since then, a lot has happened, and RAG as a sort of architectural framework has changed dramatically. Like we had two models. I think modern RAG systems have like sometimes 12 different model components that are interacting. But the core underlying idea is still the same. It's you have a language model that generates and a retriever that retrieves, and then you augment the generator with the retrieval results.
Oh, that's cool. And so with the LLM, so I mean, hell, back when I was in college, back in comp sci for like 2004 or something. I mean, neural networks and all that were around. So AI of some form has been around for a long time in functional form. Do you think these LLMs are as impressive as people think they are in the world of AI? Like, because everybody, like, it's weird. We've had some concept of AI for at least a decade, functional in production. And then all of a sudden ChatGPT comes out, and now everybody's scared about the robot apocalypse. Is ChatGPT or those LLMs are they as pivotal as people make them out to be, or are they just another step on the road and there's going to be something else in another couple of years?
Good question. So first of all, maybe a small side anecdote. One of the fun things for me is I went to Cambridge for my master's, and I got this advisor, and I was like, I want to work on neural networks, and this is in like 2011. Uh, so I guess I'm a bit younger than you, and so they that person was just telling me straight up, like, don't work on neural networks. They don't work. And, and I told him like, "Are you sure?" And he was like, "Yeah, yeah, don't bother." And so I changed advisors. I was like, "This doesn't make any sense." But that so 2011, right? That's the year that Word2Vec happened, which basically started the whole like language modeling revolution. And it's the year that AlexNet happened, which was the first ConvNet that actually worked properly on ImageNet, and where we sort of started surpassing human performance on object recognition. So, uh, for now that kind of seems like a silly position to have, and I think that's just kind of how the world works, and maybe 10 years from now when people ask, or like what is it, 14 years from now when people ask about language models, then that will also feel kind of trivial and silly. Interesting times we get to live in, I guess. But so on whether language models are pivotal, I think so. And honestly, I was a bit of a doomer, or what's the right word? A bit of a skeptic. I think in the beginning when this came out, I was like, come on, it's just autoregressive. It's just predicting the next word. Like this isn't special. But I think that really doesn't do it justice. I mean, that's just what a language model is. But what you can see is how useful it is when you do that in the right way, right? So ChatGPT, first of all, is not just a language model that just predicts the next word. It has been trained first to do that. So on large quantities of data, just predict the next word. And then there's a lot of post training that happens on that system to make it useful. And this is instruction following, it's alignment with human preferences. Now there's a lot of the reasoning training that we're doing on top of it. And so when you do that post training to actually sort of get the right behaviors that make it useful, it just becomes incredibly useful. So, I mean, I don't know how often you use language models, but I mean, this stuff is really useful, right?
Yeah.
So who cares if it's pivotal technology or sort of what the exact inflection point was where the technology sort of started working? I don't even think that was ChatGPT actually. That was already before ChatGPT. It's just that ChatGPT made it sort of available to the masses. It's like, oh wow, this is actually like something I can do useful things with. So in the future, we will still have similar types of applications, but they might be powered by different architectures, so not transformers anymore. They might not predict autoregressively word by word, but maybe in a smarter way. Like there's all kinds of interesting things that might still happen. But the underlying idea of just having a language model that can speak language, and when you give it an instruction, then it does the thing, that's
Yeah.
pretty generally useful.
Yeah. No, fair enough. Okay, so before we dive into actually talking about your company, the product, and all that, so I'm just curious on my own curiosity here. Since you work for Meta, and again, back in like 2020, so I don't know. I'm on the outside, so I have no idea what the hell's going on. So Meta's been working on AI for a long time, but a lot of these companies, ChatGPT, agree with it, disagree with it. You understand the business model. Microsoft, Google, Anthropic. Again, even if you disagree with it, you get where they're going. So apparently, Mark Zuckerberg is giving like $100 million bonuses to grab AI people to get them into Meta. And so he wants to become like the dominant AI force. I don't know. From the outside, he's a messaging app social media company. Like without going through NDAs, like what is their heavy focus on AI? Do they have a product offering that just most of us don't know exists? Or why are they dumping billions of dollars into this?
No, I think Meta has always been an AI company in a way,
Huh.
right?
Yeah.
So basically, I mean, obviously, what you're talking about, like, okay, it's messaging and social networks, but it's so much more than that, right? So everything that happens on that platform uses machine learning in one form or another. It's like, how do I figure out who needs to be connected to whom? Like, how do I place my ads. Like the core of their business is AI.
Hmm.
Ad placement, if you need to use AI for that, you can't just do that randomly. So I think Zuck was actually very early in investing properly and heavily in AI. Maybe he didn't follow through on it enough, actually, and then kind of had to catch up. But Fair was really way ahead of its time, and like big investments in GPUs enabled a lot of like models like Llama, like the early Llama, and things like that. But also a lot of the core building blocks of the current revolutions come from Meta, right? So PyTorch, like the components of ChatGPT are trained using PyTorch, right? So
Yeah.
Meta has really played a very crucial role in all of this. And so what their strategy is, I think there are a couple of good podcasts actually. Maybe you've heard of the Acquired podcast. Like Zuck was a guest on that, and they talk quite extensively about why it makes sense for them to treat Llama specifically as a platform, and so AI as a platform, because the the way to think about Meta is as a platform company, right? And so they kind of missed the boat, I think, on a few occasions. So with mobile, they kind of had to catch up, and they were really that was pretty tricky. But before that, they were perfectly timed, sort of, to use the LAMP stack to build like the first real sort of at scale application of that LAMP stack, right? So they missed mobile, and then I think now they decided, okay, we were going to go all in on the metaverse, and that turned out not exactly to be the right bet. But I think that so it's commendable that they pivoted very quickly and they realized that, okay, actually the next platform is going to be AI. And so how exactly that's going to manifest itself, Uh, I don't think they know, and I don't think they care because the what makes Meta such a special company, and so again, that Acquire podcast is amazing if you want to listen to that, is they're fluid like water,
Yeah.
and that's kind of built into the culture. It's like move fast. So even if you don't know the right answer, if you learn very quickly, then you can figure it out. And so just making sure that you have the right resources to learn quickly, and then over time you will get there. That's what they're doing. So I don't know if that costs like $100 million sign-on bonuses to get there, but maybe that's a different discussion. I also don't know if that's really true, by the way. If I was Sam Altman, I would say that too. It's like, oh, Zuck is paying that much. So but it's definitely interesting. Yeah, I think they will figure it out.
Okay, fair enough. Okay, so now let's actually get into RAG. So retrieval augmented generation. So one of the interesting things I've seen lately is a lot of people saying RAG is dead, and if you have RAG on your resume, they won't even interview you.
Is that true?
Yeah, that's true. So I'm kind of lost on that. Is there a reason that RAG would be like, I look at it, I'm just like, sure, I don't. Is there a reason not to use RAG?
Yeah, so maybe that's the real thing. Is like if you have RAG on your resume, that's like having LLM on your resume or something. It's like, everybody's kind of expected to know how to work with LLMs at this point.
Yeah.
Yeah, we wrote kind of a tongue-in-cheek a blog post about this with a couple of memes, and there's a website that you can visit, isragdeadyet.com, where we summarize kind of what we think is happening there, which is really that there's so much marketing around trying to sort of position against something, which is often a good way to do marketing, right? And like RAG is an obvious thing to position against.
Yeah.
That you get these weird false dichotomies. So it's either RAG or fine tuning, and it's either RAG or long context, or either RAG or MCP, or whatever comes next. And that's just a little bit silly. It's like RAG is such a like fundamental idea. It's just how do you get a language model to work on data that it wasn't trained on?
Yeah.
Through some form of retrieval and some form of augmentation. So it's kind of a dumb thing to say that that will die, right? It's just that the way you do it will be probably different, and the right way to do it, I think, is to do all of those things. So you want to do RAG, you want to have long context so that you can put more of your retrieval results into context. You want to fine tune those components if you want to maximize performance, because fine tuning is always better than generalization if you understand the specific use case. You want to make that available through MCP, do A2A on top of the agent that you built there, et cetera, et cetera. So all of those things, you should be doing all of them. And that's why I don't think we should talk about it dying, and you should, keep putting it on your resume.
Fair enough. So when we talk about fine tuning and RAG, so you say you should use those two together. That's not an either or thing then?
Mhm.
Yeah.
Yeah, so fine tuning is very good for kind of style transfer, sort of domain adaptation type things. So if you have a very specific tone that you want to hit or something, then you can do that on the language model. Or if you have a very specific kind of weird domain, then you might want to fine tune your retriever or your re-ranker on that data. So you want to do those things probably anyway if you want to get max performance, but getting new knowledge into a language model through fine tuning does not work. That's really not what fine tuning does there, right? So it can work at some point if you have lots of fine tuning data, but then you're basically just doing continued pre-training. Or if you have a small fine tuning set, then you are destroying the generalization capabilities of that model so that it can memorize this small set. So you're degrading performance to put that sort of, you're basically overriding the information. So the right way to think of fine tuning is I have this amazing language model that has like all the knowledge of the world in its parameters. And now I want to get that knowledge out in the right way. And that's what I use fine tuning for. But putting new information into it is really not what fine tuning is good for. That's what you need RAG for.
Okay, fair enough. And then when I was doing the research on you, so you replied to this article, so hopefully you know the article exists. So there's some website out there called the New Stack. and it was talking about MCP hasn't killed RAG. And I was confused. Again, why would it? I'm not even sure why those two words are in the same sentence. So, model context protocol for the
Uh-huh.
students is the standardized protocol for all these AI agents to be able to communicate. Again, a dumbed down concept. This thing about like REST APIs just for AI, essentially. So it's a protocol for AI agents to communicate. So again, you were talking in that article, why would MCP and RAG, why would they be competitive? Why
I
would that?
mean, you tell me. I don't know where that came from. I was just
Oh,
as
really?
surprised as you, I think.
Okay.
So I have seen lots of people say this, like, oh, with MCP, like you don't need RAG anymore. And
Mm,
so I think what people might actually mean is that you can just do like keyword search on a search engine. So you're still doing retrieval and you're still augmenting the generator. So I would still call that RAG, but
mm,
there's the vector database is sort of abstracted away under your MCP server rather
mm,
than like calling it directly, something like that. I think that's at least the only hypothesis I can come up with for why people might think that those two things have anything to do with each other.
yeah,
So MCP, as you said, is just a way to standardize how to communicate between sort of agents and tools. Uh,
yeah,
and so it's JSON RPC. It's been around for a long time.
yeah. Okay, yeah, fair enough. I saw that, and like I said, I was just like, well, and then you were actually in the article, so I was like, okay, maybe there's more to this than I thought. Okay, so we talk about RAG and all that. So now. So contextual AI, you are powered by now RAG. I love all these words. So many fucking words in our industry. So you're powered by RAG 2.0. So now
Uh-huh.
what is RAG 2.0?
Yeah, so RAG 2.0, I don't know if it really worked. It was really just our kind of marketing attempt to differentiate our approach from old school RAG.
Yeah.
And so our approach is really about thinking about these things from a systems perspective. So rather than just kind of like having this Frankenstein RAG version where you have like off-the-shelf embeddings in a vector database and a separate language model, and they're completely sort of separately optimized.
Yeah.
What you can do is you can say, okay, I know that this is going to be my language model, this is my retriever, my re-ranker, etc. All these like 12 models in your modern RAG pipeline.
Yeah.
I can jointly optimize all of them and make sure that they work super well together. I can use machine learning to make sure that they're trained on the same data distribution, that they are jointly learning the same kind of problems, that they learn to work together. If you do that, then you get a much better system because these systems always have kind of compounding or cascading. So cascading errors or compounding performance, right? So if you have an amazing language model, but not great retrieval, then it doesn't matter. Your language model is not going to get the right answer because it couldn't get the right information. And one step lower than that, if you don't have very good document understanding or extraction, then you can have amazing retrieval and an amazing language model, but you're still not going to get the right answer. So if you think about it from the systems perspective, then you know that you have to optimize all of these components to work well together, and then you get much better compounding performance. And that's why our system is so good.
All right, fair enough. So then we get to it. So we start talking about contextual AI then. So RAG is a technology, as I tell people. You got the company, you have the technology, and you have the product. And a lot of people get all this confused, right? Okay, so you've got RAG. So essentially you're selling RAG. So your product, what does your product look like that you're selling?
Yeah, so people can try it out. If you just go to our website, there's a try it out yourself button. But the basic idea is that it's a platform where you can build these very high accuracy RAG applications in a matter of minutes.
Okay.
So you can log in, create your account, set up a data store where you put in your documents. So those documents will automatically get extracted and read by our kind of ingestion pipelines, and then you can build agents on top. And so it really in a matter of a couple of minutes, once you have the data store set up, you can build a bunch of agents that do very different things on top of that data. So that's really all that it is. It's a platform for building RAG applications that are just very good and do that very fast. And
Hmm.
so why that's a good thing to do long term is the early success that we see with kind of the verticalized application companies uh,
Mhm.
means that if you can actually build something that is good enough and sort of end to end enough from like the end user to the data, sort of end to end enough, then you can make hugely successful companies very quickly. And so if you have one platform that allows you to do that kind of across your company, then you can build all of those solutions out very quickly. Because the companies we talk to, they don't have like two or three AI use cases. They have like 10,000.
Chris. That's fair enough. So when you're doing this, so okay, so I go to your service, I connect my data stores, so AWS, whatever, Azure, it's going through. So when you do training, like training can take days. Now you're saying this thing can be running up in minutes. Like how, but how long, Syria, like how long
There
does
is
it
no
actually take to
there is no
process?
training. It's RAG, right? So we're just ingesting it.
But doesn't
And
ingestion still take a bit of time?
a bit of time. Yeah,
Yeah.
so it depends on how big your documents are. So the ingestion can take longer, but if you just want to get a couple of documents in, that should take a couple of minutes, and then building an agent is like 10 seconds. And obviously, we give you all the knobs so that you can really specialize that agent and really make it your own. But the out-of-the-box performance should already be pretty decent with the default configuration.
Okay. And if you're doing like multiple of these agents, do you have to like pre-categorize the information? So let's say I had a company and I wanted agents for technical documentation, and I also wanted agents for people's health plans. Would
Mhm.
I have to pre-sort that information so that it's into different data sets before it gets ingested, or do I just ingest everything and you guys figure it out?
Either is fine. So you can have it in separate data stores that would be pretty clean. So if you care sort of about data atomicity, then that's a good thing to do, I think. If you
Yeah.
just have it all in one data store, then you can tag it with metadata, and then in the agent you can filter for the metadata. So just say, oh, this is only about HR, and this is only about whatever technical support.
Okay.
And you can also, even one level higher than metadata, you can just configure the agent and just tell it directly. You are a technical support one. If there is an HR request, then say no.
And say no. Okay, fair enough. So you're ingesting. So basically, as far as normal RAG is concerned for the people at home, so you chunk documents. So basically, you take parts of documents and then you overlay. So you do, let's say, line 1 through 10, and then you do line 5 through 15, and then line 10 through 20, right? And then basically you use the embedding algorithm to create an embedding of that the vector database can do searches off of. So you have the embedding in the database, and then you have the actual plain text information. So when your system is processed, so my data store is mine. It gets sent into your system. Where is that database information then being stored?
Yeah, we store that. So that's our data store concept. So you don't need to do anything on your end. You just have an object store. So it could be like a directory of files,
Yeah.
basically. Uh,
Okay.
and then that is what you push through the ingestion pipeline. And so how that works, it's a little bit more sophisticated than what you just described, I think.
Yeah.
So it's a layout segmentation model.
Okay.
Uh, so basically, it looks at the document and figures out, oh, this is a table, this is a diagram, this is text, this is, and so we have very kind of special types in the layout, like a circuit diagram or something, if we're working with a semiconductor company, right? So there are different ways to extract that information,
Yeah.
and then all of that very rich information gets chunked. And you can machine learn how to optimally chunk. So that's what we did. And then that's what you put into your database. And so that doesn't just do vector search, like dense search, it does hybrid search. And there are lots of different retrieval strategies you can apply. So that's what we call our mixture of retrievers.
Oh, okay. Interesting. So this information then is your and your systems. And so if you're doing RAG, a lot of uh, these AI systems that are being created, the idea is that it's supposed to be internal use. And so one of the concerning parts is a lot of the information that's going to be put through something like a RAG system is going to be very proprietary, possibly personal identify information, that type of thing.
Mhm.
I don't know. Can you answer this? Especially in a time period where we're supposed to be in a cyber war with China already. Um, how do you how do you make your customers comfortable with that, with you storing that level of their information on your systems?
Yeah. So we have different deployment models. We have flexible deployment models. So we have our SaaS, where it's basically just on our infrastructure. We also offer dedicated VPC. So it's basically completely isolated VPC that is specific to that customer. We can control it because we need to be able to deploy to it, but they own it technically, and it's within their kind of security perimeter. And then the final option is really fully on VPC. So the entire platform is deployed in their infrastructure. So we do that for larger production customers when they are very, very sensitive about their data. So we do have that capability, but in general, I think there are lots of things you can do around removing PII information before you actually push it into a system. And then our system itself is obviously very secure, SOC 2 Type 2, and all the sort of related certifications. Our head of security was one of the first security engineers at Snowflake. So we are very, very serious in what we do there.
Okay. Have you gotten any communication? And again, this is not a political thing with any of the administrations or what, because like everybody's pushing this whole idea AI is more dangerous than nuclear weapons, blah blah blah. So you're kind of trying to be in the center of AI. I don't know how well you're doing, but you're trying to be in the center of this world. Um, does the government actually reach out to you and try to explain how you could do things better or give you warnings or anything, just out of curiosity?
It's more the other way around, where they ask people like us to help them understand better.
Yeah, okay. Yeah, okay, fair enough. And then I saw, so you were saying that with is it multimodal? So when you're parsing the documents for RAG, so it's more than just text. So your system can understand images. Is that
Mhm.
right? Okay.
Yeah,
Is
so multimodality is really important, I think, right? That's one of the big issues I think that a lot of folks are working on right now is there's very rich information on the internet that is not text.
yeah.
So you want things to work on that too, right? And so we just mentioned like diagrams and things like that. So our extraction pipeline identifies like, oh, this is an image, it's a figure, and so I need to describe what happens in the figure in text so that I can do retrieval over
Oh,
the text. And
yeah.
then when I retrieve the image as the right result, then I can use a VLM again to say this is the actual image that I'm processing. So we have these sort of multimodal language models now, VLMs, right?
Yeah.
And so they can be used to actually look at these figures.
Well, that's pretty cool. And then when I was looking at your pricing, because it was curious, because it was saying you parse for $3, you parse 1,000 pages, which I thought was interesting, especially in the digital world.
Hmm.
It's not an amount of text or amount of storage, digital stuff. It's page.
Mhm.
Like, are you expecting just to essentially be processing old school digital documents, or like what do you define a page? Because like I could do a microfiche where I just shove a whole bunch of crap on one page and then
Right.
ship
Yeah.
it.
Well, good idea, actually. Maybe people should do that. Yeah, no, so the how so the pages are really just because we get lots of PDFs and Word documents and things like that, and they have pages, and so it's kind of the market standard to price by page. Um, yeah, for us, it's really so if you were to shove all that information, like let's say you have a 10-page document and you would shove it onto one page and then you would extract that, that's fine by us because the compute that you're spending for us is also a tenth then, right? So we have to do this layout segmentation for every page.
Mm.
But if it's one page, then we only have to do it once, not 10 times. So however you want to do it is up to you. It's like performance is probably better if you just do the 10 pages separately because then it's easier to read.
Huh. Okay, that's interesting there. All right, so we've gone over how the system looks. So parsing, so you have the multi-stage document pipeline. I think you've kind of talked about that. Then under your services is re-rank. The first instruction following re-ranker providing greater control over how retrieved knowledge is prioritized. So what does ranking look like or re-ranking look like in this kind of system?
Nice. Yeah. So re-ranking is just retrieving.
Okay.
It's basically the same thing. How these systems work, modern RAG pipelines, you never do single stage retrieval. So basically, you have lots and lots of data, right? If we have like some of our enterprise customers, they have whatever trillions of chunks, basically. So you can't really do a lot of heavy processing on that much information. Your retrieval is going to be incredibly slow. So what you want to do is you want to do a first sort of cast a wide net, do a first stage of retrieval, then you get your initial set of retrieval results. Maybe you take like the top 1,000 or something that are sort of maybe useful. And then on top of that, you have a separate retriever that is now smarter and has more neural network parameters, uh, and which you can afford to do because you have fewer examples that it needs to retrieve from. And that basically rescores those 1,000 examples and says, okay, I'm going to take only the top 10 most important ones. And so that's what a re-ranker is. It's basically second stage retriever, and you can cascade these even further. You can do like, third and fourth and fifth stage retrievers if you wanted to. So what's special about what you just said with the instruction following is that our re-ranker can be told how it needs to prioritize the data. So a standard re-ranker is basically just a fancier retriever that says, okay, I'm just gonna like reshuffle it according to what I think is right. But what we do instead is we say you can specify what is right. So you
Mm,
can say, okay, maybe you care a lot about recency, right? I want most recent document first based on the metadata. So that's going to be very important. And if it's from the CEO, then I think it's more important than if it's from an intern. So sort of like the author kind of importance is a factor. Or like if it's a PDF document, it's probably more important than some random Slack message somewhere. So that type of data hierarchy it's very natural in a RAG system to want to have control over that. And It wasn't really possible to do that up until recently when we announced these instruction following re-rankers, where you have very fine-grained control over how you prompt your retrieval system, which is actually very similar to how you prompt your language model, right?
mm.
But now you're doing it on the retrieval side rather than on the generator side.
That's interesting. So when you start talking about, so with the retrieval and the re-ranking, so one of the things I tell the students is whenever you're building these systems, make sure you understand what the hardware utilization is. So when we talk about AI, nobody will shut up about GPUs. Great, GPUs are fine. But like when you start talking about like vector databases, so normally when I think about databases, I think about IOPS. So basically the input output for the drive, the storage unit. So when you're doing vector databases though, where is the bottleneck? Like is that CPU intensive? Is that still IOPS intensive? Where is the hardware utilization there?
Good question. I'm not a vector database expert, but I think it depends honestly on how big the vector database is, right? And so there are different trade-offs to make there depending on the kind of scale that you operate at. If you have to be sharded, it's very different than if you can fit it all in memory, which is a lot cheaper, right? So it depends basically on the size of the vector database where the bottleneck will be. But you're right, I think it will be IOPS as the main one for a lot of this if it's not in memory.
Oh, interesting. So along with that, so do you, I mean, are you allowed to say, do you own your own hardware? Are you one of those people out there bidding for God knows how many GPUs, or do you outsource to, AWS or whatever for that type of thing?
Yeah, so I don't think any startup should own any GPUs. You should
Oh,
just
hmm.
lease them.
Okay, yeah, yeah. Fair enough. So then we get to generate. So part of all this is you've got an LLM. And so I always loved like the wording because I always wonder if it's actually marketing or technical. So you have the most grounded large language model in the world, engineered specifically to minimize hallucinations. What does that mean to a tech professional? That sounds great to a normal person, but like what is grounded? Like what does that mean that you have the most grounded?
Yeah, so what that means is that this model only talks about what is true in the given context. So you do your retrieval step, right? You find your evidence, and
Yeah,
then you give that to the language model as context. And then you say, this is what you should consider true.
yeah,
Anything that is not in this context, you should not talk about, right?
yeah,
Because and that's really what you want to have in a lot of these systems where, especially if you have like, so if it's in a regulated industry or, if you have very high accuracy requirements, you really do not want to hallucinate.
yeah.
And so that's something I always have to explain to people is hallucination for a general purpose language model is kind of a feature. It's not a bug. When you are brainstorming with ChatGPT about like cool ideas for your next project or something, it's basically hallucinating project ideas,
Hmm.
right? So,
Hmm.
so the hallucination is a good thing there. But if you have a RAG problem and you care about giving the right answer, then you really do not want that type of hallucination. So we have a language model, this GLM, the grounded language model, that has been really specialized to only talk about the ground truth that was retrieved. And so this is just really good at being grounded in that context. If there is information in there that's not relevant, then it will just ignore it. If there is no information, it will just say, I don't know, rather than making something up. And so that is really a killer feature for a lot of RAG systems, it's very important that you can say, I don't know when you don't know. And so this language model is not good for brainstorming. It's not good for creative writing in the marketing department, and that's on purpose. It's really just the best for RAG.
Hmm. So is that based off of, so at first I thought it might just be some kind of fancy ass prompt injection. So
Yeah.
so when you're doing the training then, because all the other AI companies want to gobble up every bit of information in the world and then wonder why it says some weird stuff.
Mhm.
So with the creation of yours, is it gobbling up all the same crap? It just has a different like set of instructions once it's gobbled that up, or do you actually target it at cleaner data to make it a better system?
So we're still using open source base models to initialize this, and
Mhm.
then we're doing a lot of training on top. So those base models, they gobbled up a lot of stuff,
Yeah,
right?
yeah,
That's kind of how you train a base model to begin with. And
yeah.
then during this kind of post-training, or I think in this case, continued pre-training is more appropriate as a term. We're basically continuing from that base model to just train it so that it can only talk about what's in the context that is given. So you really change the parameters so that it will never talk about any of the knowledge that it has unless that knowledge is given in the context as a result of a retrieval step.
Yeah. Okay, interesting. And the final part is you have this LM unit, I guess.
Mhm.
Our evaluation optimized model for preference, direct scoring, and natural language unit test evaluation. I'm not even sure what that means. Can you explain what that might mean?
Nice. Yeah, so what's unit testing? Maybe that's a good place to start, right? So if you're a software engineer and you as a computer guy probably have lots of people listening in who are software engineers sort of by background, unit
Yeah.
testing is really a crucial thing in how you develop software, right? So you can even do test-driven development where you first write the tests and then you write the code to correspond to the tests. So unit tests are just very fine-grained, very sort of atomic, small tests to ensure that something is correct. And so when you think about language models and language model outputs,
Yeah.
you actually want a very similar thing. So what people are doing right now is they're saying, "Oh, here's my like correct answer." So let's say you have some expert subject matter expert in your team, and you give them the question. They give a really good long answer, and now what you want with your language model is to have something similar to that correct answer. So what we do very often now, which I think is wrong, is we use language model as a judge. So we basically give both of those to a language model and we say,
Mm,
are they equivalent? So it's like model-based
yeah.
equivalence. And
Yeah.
it's and that is just not capturing the nuance, right? It's basically so like let's say in this one I had a link at the end and in this one I don't. And now it's like, well, they're not exactly the same because the link is missing, but how do you even quantify that difference? So what it's much better to say this is what the right answer looks like. These are all the particular things about the right answer that make it right. And these are the things I'm going to independently check for in the language model output as
Yeah.
tests, and
Yeah.
then score the aggregate of those. So that's what we're doing with LM Unit. So it's really a model that has been trained specifically
Mm,
for evaluating whether these small unit tests are correct or not. And so we're using that as our reward model internally for training our own sort of larger models, and it's really that much better than having this kind of binary, almost like language model as a judge. Like, are these two things the same or not? That just doesn't capture the richness of the information that you want to capture there.
huh. So I guess that's an interesting question. And it's probably like, what is a bushel of data? But so with these LLMs, so like with normal unit testing and normal testing, then you can come up with your scripts and you can run it 1,000 times and figure out how many yes and no's and figure out if it's accurate enough.
Mhm.
LLMs, yeah, you're getting stuff across the board. So
But it's the
how,
same thing, right? So we have a blog on our website. We did a collaboration with Circle CI,
yeah,
where they can plug the LM unit API call directly into a CI/CD pipeline.
yeah,
And then every time there's a change in your code, you can reevaluate whether your language model unit has still passed.
okay,
And so that's really important because as we all know by now, if you change like one or two words in the prompt, that can
yeah,
have very big unforeseen consequences, unfortunately. So you
yeah,
need to build this into your CI/CD.
yeah. So then how much, like when you're thinking about building out your team for AI, like for every 5 people, should you have one like testing type person? Like, because it does sound like there is more work for this type of testing than normal code testing.
Oh yeah,
So
absolutely. Yeah,
yeah,
so we have our own dedicated data team, and we have lots of folks working on evaluation, including like pushing the boundaries on what you can do with evaluation, like this LM unit work. But in general, I think for a lot of companies, if you think about like the jobs of the future, at least for the next sort of five years, like
mhm,
data science on AI inputs and outputs, that is a very big important topic still.
yeah. Ah, fair enough. Okay, so kind of moving on then. So we've talked about the company. Is there any more products or anything with contextual AI?
No, all good. Yeah, thanks for for letting me go over all of them. I appreciate the opportunity to tell people about that.
Yeah, well, I mean, it's interesting stuff. Even if they don't buy it from you, they should know it exists. Okay, so contextual AI, I was looking at your funding. So you've got $100 million in funding now, or somewhere around there. You just had like an $80 million funding round not that long ago.
Mhm.
So for the people here that are interested in startups and all that, when you look at getting $100 million in funding, like do you have a breakdown? Do you know what you think you're going to spend that money on? Like when you go and say, how do you know whether you should get $1 million or 10 or 5 billion? Like where does 100 million come from?
Uh, yeah, you definitely need a plan. And so I mean plans change, right? So it's okay if that plan is not actually what you end up doing. But you can't just go to a venture capitalist and say, I want this much money, and then not expect them to ask, like, oh, what are you going to do with it? So you definitely need a plan. I think for us, especially during the seed round, the biggest factor really was around compute. And so if you work in AI, like especially I think like 2 years ago, it was even more true than now. You just need to be in control of your own destiny through being in control of your compute. I think now that's maybe less true because language models are much more commoditized. There are different good open source ones out there. There are APIs kind of all over the place that you can just plug directly into your systems. So maybe kind of the compute workload is shifting much more towards inference. And so there are much more established solutions for that, but you would still need money to pay for that inference.
Yeah. So when you're looking at it, I mean, is the majority of that money then actually going towards compute, or is it going like, because we hear about how much AI people make. So is that salary, or is that basically all going to compute and a little bit of salary?
It's both. So obviously, like AI talent, yeah, they deserve good salaries because it's very scarce as a skill, right? So, but yeah, the by far the two biggest factors are compute and payroll.
Yeah. Okay. And then when you're looking at the hardware, so again, on the world stage right now, we've got this whole AI diffusion rule and this whole thing that we don't want more advanced hardware going to other places. One of the things on the outside when I look at this, I do wonder, have we hit kind of a plateau of sorts in the AI hardware world, kind of almost with smartphones, where yes, you can get better, you can buy better, but the one you got's probably fine.
Mm.
Like when I talk with a lot of AI people now, it doesn't hardware is still expensive. It doesn't seem like it's quite the cutting edge that it was even three or like, you know what I'm saying? Like,
Mhm.
are you finding that it's plateaued or do you need like the next cutting edge thing to do whatever it is you're doing?
Yeah, it's a good question. I think like so depends on what you're doing, I guess, right? So like the gap between like A100 chips and H100 chips
Yeah.
for the different types of GPUs, that was a massive gap.
Hmm.
And even the A100 before that, with the V100s, that was a big gap. Also, just in like net new capabilities. And so with the newer GPUs, I think that still needs to be proved out a little bit, sort of like whether it's worth it. And with the H100s, I think people were just really desperate to just get them in their hands. And I agree with you that now I don't see the same urgency, but maybe that's just a matter of time where I'm also kind of scared to just move on to whatever the next thing is without first kind of hearing from other people that it works and that it's worth it. So yeah, it's kind of a chicken and egg situation, maybe.
Fair enough. Well, with that hardware too, like Amazon is coming out with their new dedicated processors that aren't NVIDIA. I know Google has some type of those. We hear about ASICs processors, special processors just dedicated to AI. Have you seen that kind of like how do you have a feeling about whether those are going to replace NVIDIA or whether they're good enough or
Yeah, so I mean TPUs from Google have been around for a long time, right? And so they work really well. I mean, people internally in Google use TPUs to train Gemini, right? So I mean TPUs work. And I think it's the same with Trainium and Microsoft has projects, Meta has projects. So that is definitely happening. But then at the same time, if you just look at why NVIDIA has such a special position, is also just software, right? Like they have like CUDA is just amazing. And so PyTorch works really well with NVIDIA GPUs. With
Yeah.
other GPUs, it's a little bit more hit and miss.
Hmm.
Right. So there are all these kind of like dependencies that are almost a little bit hidden, but they really matter for the overall sort of experience.
Yeah. Okay. Interesting there. And then one of the things with this, again, in the AI world, with everything going on in the planet right now, like with the AI diffusion rule, you being in the AI sphere, because again, a lot of my viewers, a lot of my students are foreign or non-American. Don't call them foreign, they're non-American. Can can AI be contained? Like I feel like the politicians have this idea, like AI, it's as a concept, somehow we have the power to contain it. You're deep into this world. Is it containable? Like if you have $5 trillion and build a really big wall, can you keep the rest of the world from getting it?
So I'm also a foreigner, by the way, so I sympathize with those people.
Yeah.
But Can it be contained? I think we've already seen that it can't, right? I mean, like DeepSeek was a great example, and so I think it's not a very smart sort of long-term strategy, I think, to try to limit things like hardware access. I mean, what you're probably going to do is wean the Chinese market off of US companies, and now Huawei is just going to develop their own awesome NVIDIA alternative that they're using. So I think it's very short-sighted to try to intervene on something like that. I think it would be much better to be more confident about what makes America great. Not sure if the pun is intended there. But I think that's really about like innovation and so making sure that you um, get the best talent in the world to come to America and to stay here and to do awesome things here. And that is always why the US has been really great on the technology front. And that's what they should invest in and not sort of be defensive and try to block technology for other countries.
Yeah. Okay, fair enough. And then for my international students too. So you're in Stanford, you're in Silicon Valley, rah rah Silicon Valley. Let's say they're not able to get to the United States. Is there someplace like in Europe? Is there someplace else in the world that might not be Silicon Valley, but it's good enough, like Berlin or something? I don't know.
I mean, seriously, there is no place like Silicon Valley. And so when I heard people tell me this when I didn't live here, I was like, that's bullshit. But now that I live here, I think it's true. But that doesn't, I don't mean that there's anything wrong with these other places or that you can't do amazing things there. It's just Silicon Valley is this unique mix. I guess at the start we talked about, right? This very unique mix where it's basically about this like local network that is really just yeah, investing in innovation and changing the world. So you can just feel that when you're here. But at the same time, like if you want to do a startup in New York or Austin or I don't know, somewhere in the middle of nowhere, you can do it too. It's just going to be a little bit harder. And then outside of the US, yeah, there are lots of great places. And one of the advantages, I think, of the modern globalized world is that you have access to the same technology almost everywhere in the world. It kind of depends. So I guess the hardware discussion from now is one of the limitations. But other than that, so if you're in Europe, like all of these countries are investing heavily in technology as well, and they're great places to live, probably better than most places in the US in terms of quality of life and work-life balance. So yeah, the world is your oyster.
Okay. Have you heard of anything that sounds exciting though? Like I know in Europe they just had NVIDIA's, I think it's called the GTX conference, and they're talking about UK is going to be a hub of AI. Everybody's place is going to be a hub of AI.
Every country is the hub of AI. So I'm Dutch, right? And so the Dutch government is very serious about investing a lot of money to become a hub of AI. And
Yeah.
so there are great universities in most European countries that are sort of doing their thing. And so yeah, everybody wants to be the hub. I don't think that's what I mean, right? So outside of Silicon Valley, I think everything else is kind of secondary. So London is great, Paris is great. I think Amsterdam is great. Lots of other places.
No, fair enough. And the final one on this, and the uncomfortable note. So you are Dutch, and so you're here currently. I'm sorry about my president. Anyways, does this affect you at all as a professional? Because I mean, this shit's, I mean, like, I don't know what the fuck's going on. Anyways, but like, do you actually think about what's going on in a practical term, or is it just what's happening on CNN and whatever?
No, so obviously, I think it affects the world, right? And so I'm also just worried about the much longer term repercussions of some of the policy that I've seen. Let me put it that way. Uh, yeah, and obviously, like my friends and family back home, they are asking me like, what the fuck is going on?
Yeah.
And it's hard to explain sometimes. Yeah, I
Yeah.
don't know if I can explain it.
Yeah. All right, fair enough. Well, we only have you for an hour, so I'll just finish up with a couple of questions here. So, I've talked with a lot of startup founders. Literally, was just talking to a $2 billion startup founder who said basically he had devalued college degrees. Like literally, college degrees get no point value in his tech startup. That's $2 billion and 800 employees. I noticed though with your company, it seems like even the lowest level position you want a master's degree.
Hmm.
Like, so in the AI sphere, do you want a university degree because you're used to university degrees, or is that still valuable in your world?
I think it's still valuable.
Okay.
So university degrees are not just about knowledge, they're also about life experience and network and being able to conduct yourself professionally and all the other things that you learn in a university kind of indirectly. So yeah, I think it's important to get a good education and people should get a good education.
Yeah. Okay. And so you're teaching at Stanford and you're in that area. So a lot of my viewers are not going to get to Stanford. Is there, like for somebody like you, when you're looking at hiring somebody with a degree, are there properties of universities that you like to see that's valuable?
I wouldn't look so much at universities beyond sort of the obvious ones. I think you can go to a non-obvious university, but still do like amazing open source projects or other things that you can do to stand out, right? Like write an impactful paper yourself from an unusual place. Like if I see that happening, and I have actually like hired people who did that, where they were in a very unusual place. They wrote this amazing paper. And I was like, how did you do that? Imagine what you could do if you were at a place like Stanford where you had a lot more resources and support. I think you can almost use it to your advantage if you come from an unusual place.
Oh, cool. Fair enough. Well, we've hit the hour mark, and I don't want to take too much of your time because you're a very busy person. Is there any final thing you'd like to say, folks at home or on YouTube when this goes up?
Uh, no, nothing in particular. I think we covered a lot of ground. So I always like to give maybe some general advice about how to conduct your life is that uh, you should always try to feel uncomfortable. And if you are not feeling uncomfortable, then you are not learning enough. So then you need to get out of your comfort zone and get to the next level. So yeah, cherish the feeling of feeling uncomfortable.
Good. Cool deal. Well, thank you for being here. Everybody else, so we'll close out. I'll kick you all out to the waiting room. So it's basically over. The video will be uploaded in within 24 hours. And hopefully we're going to have Louis Rossman here for our next one of these. So I hope I'm trying to do these about once a week, just so everybody knows. Again, try and we'll see how that works. So thanks for being here, man.
Thank you. Thanks, everyone.